Wonderful. So welcome and good evening to the Northwest EcoBuilding Guild's May Education event. I'm Nina Olivier, one of the education volunteers, one of the many education volunteers here at the Northwest EcoBuilding Guild of a small committee that puts on monthly education events and other collaborative events. And we are so excited to welcome two speakers this evening for our event. As you just heard, this meeting and webinar is being recorded and will be made available to Northwest EcoBuilding Guild members through our membership content and webinar replay forum, as well as to folks who registered via Eventbrite. A link of the recording will be provided. As you can see, this is a collaborative, very casuals type meeting. So if you do feel comfortable turning on your video and wanting to unmute during question and answer sessions, feel free to do so. But if not, feel free to also just leave your cameras off during the meeting, and welcome. And we'll go ahead and start with our land acknowledgement. The Northwest EcoBuilding Guild acknowledges that we work on the unceded traditional land of the Coast Salish peoples, specifically the First People of Seattle, the Duwamish people, original stewards of the land past and present. We honor with gratitude the land itself and the Duwamish tribe. We welcome you all to learn about the traditional Indigenous lands you live on by visiting Native Lands website that will be posted in the chat. As we understand, not all folks calling in tonight are local to Seattle or the Pacific Northwest. We welcome you to learn more about the native lands you live on. Welcome. As I mentioned, this event is being recorded. Please try and mute your microphone during tonight's presentations. However, after each presentation, there will be time for a question and answer session. And as I mentioned, if you feel comfortable, turn on your video. We'd love to say hello and your microphone and hear a couple questions. If you have any specific logistical questions or challenges, please feel free to email me, and I'll also post my email in the chat momentarily. I'd like to start tonight off with a sponsor thank you. Northwest EcoBuilding Guild is a 501c3 nonprofit, and the programs and events we put on would not be made possible without the support of our sponsors. We'd like to thank Pathway Design and Construction. They create beautiful, intelligently designed living spaces for discerned homeowners in the greater Puget Sound area. They were founded in 2008 and are now boasting a team with well over 100 years of combined experience and a full-service remodeling firm that uses sustainable, efficient processes, low-emitting materials to match tonight's event topic, and they create and craft healthy homes that enhance the lives of their clients. Led by both brothers Paul and Mike Kacharhook, Pathway is recognized as a certified builder by the BIAW of Washington. And they are committed to quality and demonstrated ability to deliver exceptional results. They believe they have the ability to protect our planet for future generations, both as professionals and individuals. And they also support initiatives that promote stewardship and social responsibility and view their role as a leader among builders and thriving environmentally conscious communities of Western Washington. Thank you so much, Pathway, for your continued support. Another highlight this evening is King County Green Tools. The Green Tools program is a fabulous program designed by King County to help all stakeholders green their built environment while addressing critical environmental issues such as global warming, habitat restoration, solid waste reduction, and community planning. Green Tools provides technical assistance, hands-on trainings, policy development, checklists, you name it, through community partnerships and public and private sectors. I'll post their link in the chat. I welcome you all to check it out. It's a fabulous website where you can download standards, resources, checklists, the Evergreen Sustainable Development Standard, and a variety of tools. So highly recommend checking them out, and thank you for your sponsorship. A couple of upcoming events. We're super excited to be finally offering our first hybrid event of the year. On June 26th, we'll be delving into understanding inclusive design with speakers talking about going beyond ADA and what that means, as well as planning for aging in place design. And then we're super excited to collaborate with Passive House Northwest on a film screening called In the Pursuit of Passive. Date and location will be determined, but most likely we'll be hosting it at the local Columbia City Theater. So stay tuned on our social media networks as well as our newsletter to hear more about that fun collaborative event. In July, we'll be talking with some speakers about uncovering the housing crisis and solutions. While there are many to the affordable housing crisis, what people are doing on the ground today to address our current housing crisis. And then on August 28th, we have our annual Northwest EcoBuilding Guild picnic. So we hope to see you all there. Those are some upcoming events. Super excited. I'll drop the link to our website in the chat momentarily, where you can sign up for our bi-weekly newsletters that keeps you up to date on our events, as well as partner events such as AIA, Passive House Northwest, and other partners such as Earth Advantage for opportunities of other programming and events, while also announcing our upcoming monthly education events. And then for those sorry about that. For those who are interested in the in becoming a member of the Northwest EcoBuilding Guild, I highly recommend you checking out our membership opportunities. There's a ton of benefits that come with becoming a member, including access to on-demand training videos, such as our past webinars and events that we've recorded, on-site tours, discounted pricing on all events, a feature on our Green Pages directory, technical expert forums, and other networking opportunities. I'll also post a link in the chat. Highly recommend you checking out our membership program. Without our membership, events and programming such as our Northwest Green Home Tour and the Northwest Green Building Slam, as well as our monthly educational series and partner events, would not be made possible. So please check that out. And lastly, I'm super excited to introduce both speakers tonight. Our first speaker is Risa Suzuki, owner of Healthy Homes Northwest, has been a certified building biology environmental consultant since 2013. After overcoming her own health sensitivities, she helps individuals and families create healthier environments by identifying and eliminating harmful toxins that can potentially lead to disease. She is a member of the National Association of Environmental Medicine and Northwest EcoBuilding Guild and serves on the education committee for both organizations. We are so excited and happy to have Risa tonight as one of our opening speakers. And thank you so much, Risa, for being here this evening. And our second speaker following Risa will be Peter Sundgren. Peter is born and raised Seattleite and has been in the sustainable, healthy building materials space here in Seattle for 20 years. As a young contractor and customer at Environmental Home Center in the late 1990s, Peter quickly found his place of passion, hi Peter, to change how architects, designers, contractors, and building owners thought about their sustainability goals and how to achieve them. Peter joined Green Home Solutions in early 2014, spearheading the trades and sales team, and has played an integral part in the business development of sustainable, healthy products and brands in the Pacific Northwest market. We're so lucky to have you this evening, Peter. Welcome. And thank you both to our speakers. I will go ahead and hand it off to our first speaker. I'll go ahead and stop share. And I think, Risa, you should have screen sharing abilities at the bottom. Should be a green button that says share screen with an arrow. Should allow you to get going. Thank you both to our sponsors and our speakers. I'm really happy to have you this evening.
You bet. Okay. So can all of you see my slides?
Yes, that looks
Okay.
great.
Lovely.
Thanks
I
so
feel
much.
like I'm rolling the dice with Zoom. Okay, so let's go ahead and get started. I have lots of information. Okay, so I'm going to just run through the agenda really quick. I'm going to do a quick intro. Nina already did an intro, so I don't need to say too much. I'm going to talk about what is, quote, good indoor air quality. some of the standards or lack of standards, and then other things like symptoms that folks that I see when I'm out assessing homes, questions, corrections, and things like that. I'm also going to cover some air quality monitors. Included with that are sensors, which you'll learn more about, and then other client observations, trends, and etc. And then time for Q&A at the end, although we probably can do it with Peter too, since he's going to be dovetailing onto my presentation afterwards. So as Nina said, I'm from Seattle. I've been a building biology environmental consultant since 2013. Building biology is it's a 3-year certification process, and it's a combination of building science, so understanding how and why buildings fail, and then how to, things to look at to correct the environment, which includes air quality, water, mold, electromagnetic fields, and building materials. Building biology started after World War II in Germany when they were doing the rebuild, and all of the buildings were using prefab materials, and then people started getting sick. So that's basically how that started. And then, as Nina mentioned, I got into this because I had immune system issues and things to address for my own health, and that's what drove me to building biology, although I do come from a software technology background. So what I do, I work mostly with individuals and families, and then, as I said, these are my main focus areas. So air, water, infrared molds, EMFs, kitchens, and when I work with buildings, from a contractor, new build, remodel, it's typically in the design phase as they're looking at what are we going to change and how can we make it healthier. Just a quick side note here, as I go through some of these standards, the building biology standards are going to be different than the government standards, because building biology looks at what is the threshold that a grown adult can take with toxins, and that is their priority. Whereas the government standards are, what is the absolute threshold where your whole system tends to tip over? So the numbers that you'll see with building biology, they're going to be much more conservative because they're focused on when do you start feeling bad versus when do you collapse. Okay, so indoor air quality, why it's important. We spend about 90% of our time indoors, and the average adult spends, or they breathe in 8,000 to 9,000 liters of air every day. That's assuming that there's going to be 4 to 6 air changes per hour at 90 liters per hour for a 10 by 10 room in order for that air to be considered good quality. When we think about toxins in our homes, there's 4 ways that we absorb them. First is we breathe them in. So obviously that's going to be very relevant for air quality. So the most common of these are going to be the particles, vapors. They travel directly into your respiratory tract and then into your bloodstream. You can also swallow, ingest them. So that's, if you're breathing through your mouth, that goes straight into your digestive tract. And then there's the absorption, which is going to be through, you touch something, so it's absorbed through your skin, maybe you rub your eyes, or it just comes into contact with your eyes. And then there's injection, so you might get poked with something that is contaminated, where it, breaks the skin, and then all of those toxins enter into your bloodstream that way. So what is good air quality? One of the things that I see quite often is that most people think, I have pretty good air quality in my home. And in the back of their mind, they think, well, because I have good air quality, I don't really need to do anything because I feel okay. Clients also tend to think that if the air quality is bad, it's outside of their home. And it's something that they can actually see, such as the pictures that I've got up here. And then the other piece of that is because they don't actually see pollution in their homes typically, then that also tends to not raise any red flags with them. The reality, though, is that air quality, it's based on 4 main things, which is going to be your temperature, your relative humidity, the particles in the air, which is going to be, what is the makeup of those particles? How many are there? And then what are the sizes? How big or small are they? The other factor is going to be your toxins. So all of those particles, gases, the VOCs, how toxic are those particles that you're ingesting or breathing in? When it comes to standards around temperature, ASHRAE, building biology, all the standards groups, they pretty much agree that the ideal temperature is 68 to 75 degrees Fahrenheit. The rest of the bullets on the slide, these are specific to building biology. So going back to what I mentioned earlier, which is building biology really looks at what is the health of an individual and when do they start to not feel very good. So building biology has a couple of other things that they recommend, which is the vertical air temperature shouldn't be more than 5.5 degrees Fahrenheit, 67 inches above the floor. Your indoor air temperature, the floor temperature, not just the ambient temperature, it should be between 66 and 84. And your thermal deviation shouldn't be any more than 5 degrees Fahrenheit. They also have a specific recommendation on where the heat should be stored. There's a lot just within the building biology community of storing heat in the walls, right? Because it can be very challenging because you've got wires and other things versus radiant heat that comes from the floors. But I didn't make this up. So when it comes to humidity, so I've got two standards here. So there's building biology versus ASHRAE. So if you look, and this is again where the standards you're going to see a little bit different. So building biology breaks down, hey, humidity, we think that there are 4 categories, and that's pretty consistent for all the building biology recommendations and standards. For no concern, slight concern, and then a severe concern, and then extreme concern. So building biology's recommendation is we like to see relative humidity between 40 and 60%, and then the carbon dioxide parts per million less than 600. If you look at the ASHRAE recommendations, their recommendations are just pretty much, we like the humidity to be less than 65%, and then you're good. So you translate that to the building biology standards. If you're at 65%, you're actually going to be nudging up into the severe concern for building biology. They also look at carbon dioxide a little bit differently. So they assume that your outdoor carbon dioxide is going to be about 400 parts per million, and then your indoor air quality shouldn't exceed 700 above that number. So assuming that it's, let's say it's your outdoor is 500, then your indoor quality, they wouldn't want it to be above 700. 400 is kind of the standard what they use. But again, if you look at ASHRAE's numbers, assuming 1100 total, that is in the severe concern for building biology. So when you're looking at standards, when it comes to, some of the other things I'll talk about, but just kind of keep in mind that there's different standards depending on which organization that you're looking at. All right, so health effects for humidity. Most people don't really think about humidity as being very, that it doesn't impact them very much, but it actually does. If your humidity level is less than 40%, then that's when your mucous membranes start to dry out. And your mucus actually helps protect you against dirt and viruses. It can result in allergy type symptoms, itchy eyes, sneezing, your nose and your throat. Also, it can increase your bacteria and your virus growth. And there's also an increased chance for ozone production. If your humidity is above 60%, then you also get increased bacteria and viruses, including mold, especially if you're in a warmer climate, and also more dust mites. The other thing to note with this is that if you have chemicals, like if there's VOCs, there's just been a remodel or it's a new build, then there's also going to be more activity in the air. So that's another thing to consider when you've got high humidity levels. Another interesting thing is that if you have less than 40% humidity, dust mites cannot grow when it's less than 40%. Okay, so particulate standards, this is another area where you're going to see two different types of measurements. So the first thing is that the EPA they actually don't have indoor air quality standards when it comes to particulates. Particulates that's the stuff that's floating around in the air, like dust and pollen and mold, things like that. So the building biology recommendations are your particulate counts. They should be 70% or less than whatever it is outside. And that applies across the board to all sizes of particulates. The other thing I wanted to point out is that when you're looking at particulates, there's a lot of buzz around PM10 and PM2.5. That has to do with the size of the particulate. For example, PM10 is 10 micron, PM2.5 is 2.5 micron inside. The EPA does have outdoor standards. So below, I've got a chart which shows you how basically the two measurements that they have for the outdoors air standards. So the first one is for PM2. Basically what they say is on an average day, we don't like people to have more than 50 micrograms of particulates, 10 microns, and that's per day. For PM2.5, again, it's calculated by weight. So for PM2.5, the particles are going to be much smaller. So you're going to have more particulates that aren't going to weigh as much. The second line there, when it talks about the daily concentration, what that means is that for any given day in a year, they don't want to see a maximum intake of 150 micrograms of 10 microns that are 10 microns, particles that are 10 microns in size. Sorry, it's been a long week. For any given day. That's the max threshold that they would want to see within 24 hours. However, that's only for outdoors. And your indoor pollution is always much more, it's just much dirtier inside than it is outside. Okay, since we started talking about particulates, I'm going to talk about the particle sizes and marketing, because this is where I see everybody when I say everybody, a lot of my clients don't understand this. So we talked about how there's different sizes. So particles that are 10 micron or less are what we call inhalable, meaning we just breathe them in and our immune catches them and then we get rid of them. However, if the particles are 0.3 micron or less, then it's too small for our immune system to catch and then get rid of. So they just remain in our bodies, usually in our lungs or in our bloodstream. Just to give you a reference point, mycotoxins can be really small, and they will be as small as 0.01 micron. So here in this chart that I pulled up, you can see on the very far left, there's a table of particle sizes. And then, so there's, 10 to 30, 5 to 10, 3 to 5. And I have circled 1 to 3 because right now the buzzword is PM2.5, which is, what a lot of the air filters say, we have PM2.5 filters. We can filter out X percentage of the particles in your area. And then on the bottom those are the particles that you really need to pay attention to because they're smaller. So going over to the next column to the right, that's just the number of particles that there are within the given area, the percentage. And then I have two breakouts by particle size and particle weight. So a lot of times when you see an air filter that's being advertised and they talk about, we get rid of 97% of the particles. If you look closely, most of the time, they are not filtering down to 1 micron. They're only filtering down to, maybe 0.3 or, 3 or something like that. And what they're advertising is they're getting rid of X percentage of particles by weight and not by size. So as you're looking at air filters, you need to look at what particle size do they filter out, not necessarily the percentage. You can look at the percentage, but you really need to look at what the particle size is that it's capable of. And then this here is just an example to give you an idea of the different particle sizes. So I have circled the big box in red that's 45 microns. Most people cannot see particles that are 50 micron or less. A single strand of hair is about 100 micron. And then you can see over here in the far left here, I have a little teeny tiny box that I've got a little square around. Those are viruses and those are bacteria. And the measurements here are 0.1 to 1 micron and 0.03 to 0.05 micron. So you can get an idea of how big they are compared to something that you can barely see. And then here I've got some examples to give you an idea of what are the different particle sizes for different things that we know about. So I have highlighted here in all of the orange, these are all particles that are 1 micron or less. So you can see that most of the stuff in our environment is going to be less than 1 micron, which again goes back to the previous chart that I showed, which shows you, what the percentage of particles are in your environment when you go by particle size and also not by weight. The other thing to think about when it comes to air quality is that the smaller particles, they don't weigh as much, so they're basically gonna spend a lot more time floating around in the air because they're not heavy enough to settle on the floor. And HEPA. So I'm going to talk a little bit about HEPA. So HEPA, it's a high efficiency particulate air filter. The requirements is that they have to remove 99.95% of the particles at 0.3 micron. So the range for HEPA is 10 to 14. You can see I have 15 to 17 here in the chart. Those are typically what you would see. They're called ULPA because all HEPA filters have different classes. You can see in the chart that on the very far right column, it shows what the class or the grade. So if you see a HEPA filter and you're buying one and it says it's a type E or it's an EPA HEPA filter, that's what it means. It's what the efficiency level is at specific micron sizes. And then, so I was getting into ULPAs. So ULPAs, that's what you're going to see like in a clean room, a hospital, anywhere where it has to be really, quote, sterile. So you're not going to really see those too much in a normal household. The other thing that you might come across is a HEPA filter that says that they are medical grade. So if a HEPA filter says that they are medical grade, then they should have gone through a testing, some sort of a certification. And that certification, they have to filter out 99.995% of particles as small as 0.1 micron. So it's smaller than 0.3. So again, as you're looking, or if you're looking for yourself or a client, you really want to pay attention to what the certification is, the HEPA number, and then the type, because you want to make sure that everything matches up and that they have the certification to back it up. Okay, now we're going to talk. I'm going to go over MERV ratings. So MERV ratings that's going to be your whole house air filtration system. The MERV ratings are from 1 to 20, and they basically have like the higher the number for your MERV system means that they're going to be able to better filter out particles at a smaller size. Depending on what the MERV rating is, you'll see in the 3 columns there, I have it broken out by the particle size. So the first range one is 0.3 micron to 1 micron. And you can see that for MERV 1 to 9, it's not filtering anything out for 0.3 to 1 micron. And same thing for range number 2. It does filter out the larger particles, which is range 3. Those are microns, 3 to 10 micron or higher. And even then, those numbers are fairly low. So if you have a MERV 1, 2, 3, or 4 filter, it's going to be filtering out particles, 3 to 10 microns, like 20% or less. So you can see as you start to go down. So if we look at a MERV rating, let's say that's 11. It's not filtering anything out at 0.3 to 1 micron, but it does have some efficiency in the 1 to 3 micron size, and it does have better efficiency at removing at the 3 to 10 particle size. And then again, these the MERV ratings 17 to 20. These are what you would see in a clean room, a hospital room, something like that, where the room has to be very, very, very clean. You don't see those usually in residential homes. Okay, standards and VOCs. I'm sorry, the slides are not really cooperating. Okay, so if you're confused on VOCs, or if it seems like it doesn't really make sense, the reason for that is because there aren't any official VOC government rules and regulations. There's nothing specifically for buildings. There are quote guidelines from ASHRAE, from OSHA, California Department of Health Services, building biology. There's different standards from other organizations, but there isn't anything specific for indoors. The EPA, however, they do have regulation around things that have to do with emissions from products. So that's going to be things like your paints, your coatings. It could be carpet, furniture, things like that. But they don't have anything about if I walk into a home and I were to measure the formaldehyde level, there isn't anything like that. It has to come specifically from a product. That being said, though, there are formaldehyde limits for composite wood products, which I'm sure Peter's going to get into. That's going to be things like your plywood, your fiberboard, particle board, and things like that. And then the table that I have here, these are building biology standards. So this is again, because there aren't any standards, and building biology looks at, what are the things that can be in an environment where people start to feel uncomfortable or just not very, very good. So the first one is in green, the comfort range. If people are feeling good, you can have VOCs up if you're healthy. This is, someone that's not sick, but up to 200 micrograms per cubic meter. 200 micrograms that's a pretty good target. Where people start to feel uncomfortable or sick, I've highlighted in red, which is going to be 3,000 to 25,000. And then some of the things that we look at from a standards perspective that we like things to be, less than, is going to be like the aldehydes and ketones, the hydrocarbons. And I've dropped in some examples to give you an idea of where you might find these products. terpenes, halocarbons, and esters. So most of these have to do with fragrances, perfumes, cleaning products, foods and drinks. A lot of times they will extend the life of things, or they'll make them, smell better, or sometimes even taste better, because sometimes they will be in food also to preserve life, make them last longer. All right, now I'm going to talk about monitors. I had some questions around what do we do, for air quality monitors. So with air quality monitors, there's basically three categories for those. One is those are going to be your professional handheld ones. You can see these are the ones here that are up at the top. These are typically going to have, they're going to be like tens of thousands of dollars. Sometimes they're as low as about like 4,000-ish. It kind of depends on what it's measuring. But a lot of times you'll have just your base handhelds, monitor, or whatever it is that you're measuring, and then you'll have single cartridges specifically for each gas or VOC that you're testing. That is the best way for determining how much of a VOC is in a built environment. And then the next one is going to be the commercial. That's going to be something that's going to be, it's integrated with the built environment. So you can see here in this picture, it could be an office where they've got the temperature, they've got the humidity, it's hooked up to sensors. If the temperature gets too hot, then the air conditioning will kick on. And then at the bottom are going to be the personal ones, which is what most of you are probably curious about. These typically have applications, and they can be integrated, with your phone or other devices in your home if you've got a smartphone or a Wi-Fi network. Once you start getting into the monitors, then that is where you have to pay attention to what the sensors are. So each of the monitors, they can use different types of sensors that are going to measure all of the different particles and then all of the different gases. So when it comes to particulate sensors, so the monitors that are measuring how much pollution, how much dust, pollen, you're going to have a beta attenuation. That's very expensive. That's something like a hospital or, like a very, very large commercial facility would use. Then actually, I'm not going to get into how that works, but it uses radiation, beta radiation, in order to calculate what the particulates are. The next best one are going to be your laser particle sensors. These are going to be your particle counters they're handheld. They usually start around like, I don't know, $35 to like $4,000. The laser will sense the particles. They have an algorithm which then can figure out how big the particle size is and the quantity that's in that environment. And then the last one is going to be the infrared. These are the most common out on the consumer market. They're not as accurate, but they're really good at saying, hey, yep, you've got particles. Here's a rough estimate. So I call it t-shirt size estimates, and some of them are better than others. But one thing to keep in mind with the infrareds is that with all of the technology and the advances, the infrared sensors are the ones that are continuing to improve. So that's something that you can expect over time, is that these will continue to get better. When it comes to VOCs, you've got your CO2 and your VOCs. Okay, so the three main gases that are measured the most, there's three types of sensors that can measure gases, and the different sensors will measure a gas better or worse than some of the other gases. So this table here, you can see the first row is for CO2. There's what's called a non-dispersive infrared, or NDIR. Those basically, those measure light waves, And that's how they can figure out what the CO2 level is in the environment. Those are usually accurate up to 1,000 particles, parts per million. Those aren't affected by any other substances, so it makes it more accurate. One of the cons is that it can be affected a little bit by temperature and humidity over the long term, but compared to the other two sensors, it's the best choice. So just going over here to the right, there's electrochemical. So electrochemical sensors, those they basically measure what the resistance is or what the conductivity is on metal, because as the gas comes in, it knows, you know, what the baseline conductivity or resistance is. And then once that gas enters, it changes, and then it spits out a you know, an algorithm and tells you what that new measurement is. And then there's medical oxide. Those going over here to the right, metal oxide semiconductors. Those heat up, and then as the particles are absorbed on the surface, then those will react, and then the electrons change the resistance on that layer. So they're similar, but they're also a little bit different. So when it comes to CO2, you can see electrochemical. So if there's other gases, it can be those readings can be affected, but it is less susceptible to humidity compared to the ender. But because it's susceptible to the cross sensitivity, it makes it a, you know, not the better choice. The metal oxide one for your CO2 readings, those are usually used where you have a pretty good suspicion that your CO2 readings are going to be higher, because 2,000 parts per million, that's usually when people start feeling sick or symptomatic. So you wouldn't want to necessarily be using that if you're just trying to, you know, find a problem, because that 2,000 part per million is going to be pretty high. Like the ender sensor, it can also be affected by temperature and humidity. It can also be affected by other gases as well. So going down to the next row, so VOCs, there's not an ender sensor for VOCs, and they can be susceptible to other gases with an electrochemical sensor, but it is better. The recommended one for VOCs is a metal oxide semiconductor sensor. These are really good for, so let's say you're measuring total VOCs over a period of time. So that's going to be the best option, and typically what these are going to be used for. When it comes to ozone, the better sensor is going to be your electrochemical, similar to VOCs. An ender sensor is not going to exist for ozone. You can have a MOS sensor for ozone, but that one also is going to be affected. If there's other gases where you're measuring, then that could affect those readings. Okay, so when it comes to purchasing monitors, the criteria that you want to look at is, one, I talked a little bit earlier about, you know, we were going through HEPA and MERV. You want to look at what the UL listing, because sometimes you'll see, you know, HEPA-like filter or medical grade like filter, or it could be PM25. A lot of times when they do research for clients, when they say, oh, I have this air filter and, you know, it's this, but they don't know what the particle size is, I'll go back and do research, and they're not filtering out small particles, but they'll say, well, it was a PM25, or it was, you know, it said it was a HEPA, but the marketing materials might say HEPA-like. So the UL listing means it has to go through all the certification and tests in order to get the HEPA certification. So as I touched on before, you want to look at what the particle sizes are that it's capable of monitoring. You also want to think about where in the home you're going to be placing these monitors, because you have to remember when you have, you have this little tiny device, and in order for it to be measuring everything, whatever is in your house, like it has to make it over to the monitor to tell you that it's fine or it's a problem. So placement or placements in the home is going to be really critical, because the range is going to be limited to whatever the device range is, which is not going to be very far. Then the other thing that I always talk to clients about is how are you going to use the data? And we all get into this thing of, oh, I want to know what's going on, but then how are you going to use the data and how are you going to take action with it? So you'll make sure that you have a plan for it. Some of the trends and awareness that I have seen is that most people typically start to become aware of indoor air quality problems when they see that, gosh, I feel worse if I'm over in this area of the home, or in this particular room, I start feeling like I've got allergy symptoms. So they typically don't really think about air quality until they start feeling symptoms somewhere. They also think about air quality when wildfire season starts and we start getting, the fire particles drifting over this way. That being said, though, I have seen a growing number of folks who they're becoming a little bit more aware of indoor quality, but their focus or what they think is it's limited to particles. So I need to get an air filter to address pollen, because spring is coming up, or I have a dog, so I should get a HEPA filter to filter out the pet dander. So they don't really think about VOCs. It's really more around the particles. The other thing that I have noticed as I've been working with clients is that people, when I first started this 10 years ago, a lot of folks were getting sick, and they were, probably like in their 50s, 60s. But a lot of my clients now are sick and they're in their 30s, which is really young. Or they're managing, some sort of like a chronic illness. So that's another reason why indoor air is so important, is because people are getting sick much earlier, and they're usually fairly healthy until, they have mold or they've just absorbed toxins some other way, and then their whole system tips over. So some of the common mistakes or corrections or things that I see, the biggest one is just understanding how different components of their house work together to create good indoor air quality. So I don't really think of it as a system. And when I talk about this, I'm meaning ducts, your crawl spaces, your portable air filters. Clients tend to think of these in very narrow silos. They don't think of it as, gosh, I haven't had the ducts. I don't think I've ever had the ducts cleaned, or I don't think I've come across anyone like that. But ducts where they can't remember when the last time was they had their ducts cleaned, or maybe it's been 5 years since they had the ducts cleaned, and the light bulb goes on that, oh yeah, that affects how I'm feeling, or I've been really symptomatic since I've been turning the heat on, or an older home that has a crawl space, and not really thinking about where the air is being pulled from, if it's being pulled from a crawl space that hasn't been cleaned in quite a while. So there's a lot of education that I think that you guys can help them with when it comes to thinking about the air quality in their home and how all of these different things contribute to their overall air quality. The other correction, I kind of touched on this earlier, is just the portable air filters that can make things worse because they're not filtering out the smaller particle. And then the other thing is that even some of the homes that have a really high MERV, like a MERV 16, those particles, you still need a portable air filter that can capture the smaller particles. Even though they're supposed to get them, the portable air filters actually do make quite a big difference when they're placed strategically in the areas where they spend a lot of time in. And then things to listen for. So as you're working with your clients, these are the things that you're going to want to pay attention to, that you're going to be able to help them out with quite a bit. So your clients who are going to be more sensitive, to the particulates, any products that have VOCs or off gassing, anyone who works from home, if they're homeschooling, or if they just spend a lot of time at home, if they have allergies, if they have respiratory issues. Same thing for multiple chemical sensitivity. About 1 in 4 people are diagnosed with multiple chemical sensitivity. That number is supposed to grow exponentially by 2030 to something like, I think it's like 1 in 3 or something like that. And that's actually an underreported number, because that's only the number who are officially diagnosed, because there's a lot of people who are actually sensitive, but they just haven't either gone to get tested, or they just kind of think it's allergies, or well, I'm sensitive when I walk into a store, and I smell something, and it but then it goes away. If your clients have had a previous toxic mold exposure, air quality is absolutely going to affect them much quicker. Same thing, heavy metals toxicity, or if they have Lyme. And a lot of these folks will also have, multiple chronic health conditions. So a lot of times, if they have one thing, there's a good chance that they have something else that overlaps with that. So any clients that have these, they will absolutely be benefit from better air quality. Some of the common symptoms that I see is that they will feel worse in one area of the home compared to another place inside the home. The other thing that they might be talking about that I've seen is, gosh, I feel better even if I leave the house and I'm only gone for a couple hours. I'm back, and then I realize I felt better when I left, and now I don't feel quite so good when I come home. Some of the other symptoms that I see from bad air quality, it's going to be headaches, lightheadedness, or just feeling a little bit dizzy. A lot of folks, and this is coupled with allergy symptoms a lot of times. So they might have sinus congestion or just itchy eyes, and then respiratory issues. So they might feel just like chest congestion, or difficult. It's more difficult for them to breathe, and they just they can't breathe in enough air, or just exhaling. And again, a lot of these will overlap, and sometimes it is immediately after part of the house has had a remodel, or a new build, or new furniture, things like that. And then sometimes it'll come up later. Like they might feel initially okay for maybe like the first month or so, and then as their immune system gets weaker from all the stuff, whether it's bad air or VOCs, then they'll start feeling worse, and then they'll have to go back and try to play detective, and then find out what has triggered, or what's changed in their environment that could be triggering it. And then I have a case study. So this is a case study of an example of good air quality. What they did, it's an Airbnb, and it's out in Woodinville. What they did is they've got clay paint that naturally breathes, because there's no sealant on it. That is going to regulate the humidity naturally. You don't have to turn anything on. It can also turn formaldehyde into a neutral element, which is really good, because it's a lot of new finishes, products, furniture. And then the other thing is that the temperature is going to be regulated by the paint density. So it's going to help keep that environment cooler in the summer and warmer in the winter. They also have a radiant floor, so that's going to, a lot of times if you have, electric heaters or an HVAC system. With radiant, you don't have to worry about all the particulates being blown around. And then the skylights are going to have the ability to open up. So that's going to release the air pressure that builds up. And that is also going to let the warm air escape without having to rely as much on air conditioners. They also have some portable air filters that filter down to 0.003 microns. So that's going to help filter out those smaller particulates. And then there's some other things that they did when it comes to, the air circulation. There's 2 doors on each side, even though it's a small space. It's going to help with the air circulation. And then for off-gassing, they have non-toxic wool insulation, and they've got a slate floor that is also low in toxins. And so if you working with me, so I work mostly in the planning and design phases for new builds and remodels, focusing mostly on air, EMFs, and water system. A lot of my clients work remote. They have children. They're managing things, like stress, allergies, or fatigue. Some chronic or serious health conditions, and some less. And if you want to reach out to me, you can reach me at risa@risasuzuki.com. If there's anyone that is looking to purchase a home, I am co-hosting a free healthy home buying seminar later in June with one of my real estate colleagues. So that is it. I tried to zip through this really quick so that Peter has enough time to talk.
Thank you so much, Risa. And if you have a link or any other information to share regarding your healthy home buying workshop on June 22nd, please feel free to post it in the chat. We did have one question come up in the chat, and others might come in as well, but great presentation. Leslie with Whitney Architecture asked, do you have any recommendations for architects, mechanical designers, specifying some of the better air filters, since these filters restrict airflow and ventilation systems?
I don't. Is that it?
And those were all the questions that came in the chat, but if folks have any more questions for Risa, please feel free to drop it in the chat, or if you're feeling comfortable, unmute, say hello. Give it a second. Yeah. Oh, looks like John just posted. He's asking, how about monitoring CO and nitrous oxide? Are there any monitors you would recommend for carbon monoxide or nitrogen dioxide?
So I don't have specific monitors that I recommend, but I gave you the criteria to use to research monitors. So you want to, right? So you want to look at the, so for metals, you really want to look at the sensors.
Great, that's helpful. And then John Novak just posted, can you talk more about how clay, which was really neat to learn about in your case study, how clay walls help with air quality?
Yeah, so clay, so think of clay, so think of, like when you go to New Mexico, so clay adds density. So literally, if I just like took a big slab of clay, and actually that clay you have to hand trowel on, it's very time intensive because you have to put on a binder, and then you have the clay. It's literally clay. So because it's porous, when it gets hot, it's going to keep your indoor environment cooler. Kind of think of it like cement, right? Cement is really dense. But in the winter, the clay is going to help. It's going to help. It's like a natural insulator. The other thing is, right, if it's unsealed, it's going to absorb your humidity level. And so as your humidity level goes up, it's going to absorb that. So I actually had clay in my place, and I would have to have, and this was in down in the central district. And I would have to have at least 3 days of 85-degree weather before it started to feel a little bit warm inside. So it's it just helps, yeah, it just keeps your air clean. And then it also, and it's American clay, and so it also can turn formaldehyde into a neutral element. So if you have a bunch of new things that are, you know, off-gassing, then it has that capability to absorb that.
Yeah. Hey, can I speak a little bit more to that?
Sure.
Erin, sure.
Oh, here's a
Hi.
fantastic presentation. I'm so glad to be here. I'm also on the education committee and the board for the Northwest EcoBuilding Guild. I'm super stoked about this presentation. Thanks for being here. So my whole office and most of my home I apply clay plasters in most of my house.
Erin, it's a little hard to
And
hear you. I'm so sorry about that.
oh yeah,
Just thought
totally. Thanks, I'll
um,
speak up.
awesome. Thanks so much.
Yeah, so I'll make this kind of brief because one of the, like, yes, clay neutralizes VOCs. There's a lot of great stuff on that front. And one of the really cool electrostatic relationships that it has with the humidity in the air is that when it absorbs moisture, so it's constantly absorbing and releasing at the same time. And when it releases the water back into the air, it the water molecule is about 50 times smaller than it was when it took it in. So it's constantly releasing tiny droplets of water, and what that does is it changes the electrostatic nature of it. It makes it negatively charged. So it's essentially ionizing the water suspended in the air forever, just passively. And so what that does, it makes the water then electrostatically attract itself to anything floating in the air, and all the particles that Risa just talked about. It attracts, so it basically makes those particles heavier and then slowly falls into the air. So like every morning I walk into my office and everything is way more, like I need to dust a lot more in my office because everything that gets released into the air, my clothes and anything is just constantly falling. But when the sun shines in, there's virtually nothing floating in the air at all. So if your house is full of raw, open clay, but not sealed, not closed off, if it's got that open, raw relationship with the water in the air, then it's constantly passively cleaning the air from an electrostatic standpoint.
The other thing too, is that the wires in the wall, you know, they produce electromagnetic fields. So with the clay wall, it depending on how many layers of clay you have, it will actually reduce those EMF fields quite a bit, like 30 to 40 per meter, depending on how strong the fields are and, you know, how big the wire bundle is behind the wall and things like that.
That's great. Thank you so much for sharing, Erin. And thank you again, Risa, for your awesome presentation. There are quite a few more questions in the chat, but I do want to give Peter some time to present. So we left off at Bragdon Shields in the chat, Risa. If you have ability to type in some responses, and or we will also have Q&A time available after Peter's presentation as well, where we can tackle any questions that were unanswered. So without further ado, I'll go ahead and pass it to Peter now, and we'll get back to those questions. But thank you again so much, Risa. Fantastic presentation. I learned so much, and I appreciated the specifications as well as the resources you provided. Really awesome information. And now I'll kind of pass it to someone who can put it into practice and talk a little bit about materials available. Peter, I'll give you the floor, and let me know if you need any help sharing your screen and where to find that. And yeah, thanks so much.
Yeah, awesome. Thank you, Nina, so much. And thank you, Risa, for your presentation. Lots of super good info there. Nina, I will say, I'm down at my share, and yes, here we are. So I will go ahead and put that up there, and I hope everybody can see quality air. Every breath depends on it.
That's great.
Yeah, you bet. Thank you. So, a couple of things real quick. I am a huge fan of American clay. I have that in my bathroom, and I also have lime plaster on my ceiling. I've never, ever had to clean mold or mildew off of my ceiling. And when I take a shower, my bathroom smells like wet clay, and it's awesome. And it dries itself literally within 20, 30 minutes after a long, hot, humid shower with a teenager. It's all dry. So very, very keen on that product. So I think it's cool to hear that product. I've had that in my bathroom now for probably 20 years. So quality air, every breath matters and depends on it, and that is for sure. And it's something that I've been doing for over 20 years in the industry, and something that I'm extremely passionate about. And you will hear that in my presentation as we go through. So why is it important? First of all, we all really know that the air we breathe, as I said, every breath of every life depends on it. And indoor air quality is really where I come into this program through the building materials side of things. We live inside. We are inside 17 hours a day in homes or other buildings on average. If you think about that, it's on average. Think about people working at home. There's people who are in their homes 24 hours a day. They do not leave their homes. And I don't really consider leaving your home, 10 minutes outside for some fresh air or a walk around the block for 45 minutes. That's not a lot of time spent outside. And if the outside air is not super healthy, then we're really not really in any good spot. It's important because we know that bad air quality inside and out causes health issues. It's why people like Riza are in business. It's why people are in the American Lung Association and the filtration industry. We know that these cause health issues, and we're all trying to combat them to make our health and our homes and our families, which we all hold of immense value and importance. So it's critical. It's not just kind of important, it's really critical, especially when we talk about health of our children in our homes, as I mentioned, and how much health care in this country costs. Often, I think many of us know at this table, because I see a lot of familiar names here on the list, we often know that indoor air quality is worse than outdoor air quality. The EPA, we know through testing and other things and other organizations that levels of indoor air pollutants are often 2 to 5 times higher than outdoor levels. So how does it happen? There's a reason why it happens, and I think most of us know for the biggest part of it, typically not enough poor air out of the house and good clean air in, right? If we could do that, take all this yucky air out and replace it with good air, well, then we're pretty much winning. So filtration and air exchange. There's a lot of folks again at the table who know about, air exchange through rooms and MERVs and ERVs and all these other cool things about moving air and different ways to combat through ventilation. We know what it does. Teresa's point kind of earlier that she had put out there and some technical numbers there. If we really translate it out, if you think about moving 5 cubic feet of air, which is not that much, per every 100 feet of floor space. So a 300 square foot room, it's quite a bit of air to move out of there if you're going to be doing that every hour. And certainly when you think about bigger homes and improper ventilation, could be extremely hard to do, to exchange that much air in the time frame that you need to do it. So that's how it happens. We bring bad air into the home. We buy things, we consume things, whether it's a plastic toy, a cheap blanket, a couch, a chair, a building product, a flooring, a countertop, a cabinet. Recently had an experience where a friend bought my child a blanket. Got the blanket home, it's chilling in the living room on the couch. I can smell it. We're like, what in the hell is that smell? And I'm looking around, looking around, looking around. I grab this blanket and I'm like, oh, what is this? I open it up. It's this funky printed blanket with all this ink. And I'm like, sweetheart, I'm sorry. This is not coming in the house. We're not bringing this in your bedroom. This is something gross. You know, we're going to air it outside for a few days. It did off gas, but I'm glad it off gassed offside instead of inside my kids' room and inside my house and inside the bedrooms of our own homes. It happens because we recirculate, we trap, and we create poor air quality, bottom line. Most homes that are on central air systems, improper filtration, we might not have the right filter in it. Filters might become very expensive for a lot of us in our community. A MERV 16 filter at $100 a pop or even $65 a pop is not the same at a MERV filter at MERV 10 or 12, right? And if you're not changing that MERV 10 out every 2 weeks, well, then you do need to have a MERV 16. So we are recirculating a lot of it. We create it in our own selves. A lot of us have no choice how we create it. I once had a friend who lived in a very, very busy street, about 2 buildings down from a metro bus station. Unhealthy. Went over to his house one day, took my finger around his window. I could not believe how black my fingertips were and how dirty. We were talking about how he often replaces his filters that he has in his home. It really was mind-boggling, and I certainly didn't hang out there very long. It happens because we bring these things into our home. As I mentioned, these items, some of us, we have no choice. Again, they help us function throughout the day. Some of these items are made from materials, from ingredients, natural and synthetic. Some are treated with toxins and some are not treated, especially in the building materials market. Think about fabrics and foams, and think about coatings on different materials and things. What are some of the biological and chemical pollutants that are common in our indoor air? Some of the biological contaminants we think about, obviously this is your molds and bacterias and mildews, obviously viruses. We are familiar with viruses. You think about your cat and your dog and your animal dander, common dust that's in the air. There's bugs, there's mice, there's rats, urine, there's bugs, there's pollen. It's all things that a lot of it are out of our control. But urine dries on the floor from the rats, and that becomes airborne pretty quickly in the air, and we're inhaling that, and that is a biological chemical. Chemical contaminants, we all know carbon monoxide, formaldehyde, pesticides. There's a reason for a cat collar. It's to kill moths, or it's to kill the larvae and the bugs and the things that are crawling on your cat called fleas. That's a pesticide, and that pesticide's in your lap, So there's a lot of real things that we just can't avoid, that we look right under our nose. Lead, VOCs, nitrous dioxide. One of the biggest culprits of nitrogen dioxide is, a gas stove. Everyone loves, I'm a foodie. I would have loved to have had a gas stove with that pilot lights all the time, that nitrogen dioxide. No, thank you. I'll look on a glass top. So for us in the building materials world, and I think we all need to think about and ask, well, is anything being done on a bigger scale to fix indoor air quality in our buildings, in our homes? And the answer is yes. Manufacturers are meeting the demands of consumers. They're creating products made in more cleaner and more energy efficient facilities. So this is attributing to good outdoor air quality, right? So that's a bonus. You cannot, remember, you can't have good indoor air quality without good outdoor air quality. Manufacturers are using and researching, developing chemicals with lower VOCs and lower toxins. I do have a question mark there, and I have 2 questions marked there, because I do wonder often in my career, is the next good, clean, healthy chemical floor or chemical coating or chemical product going to be the next asbestos or lead pipe or XYZ? So I do think we have to be careful about developing the next best chemical and how those future chemicals are going to affect us. And there's a way on many scales to deal with that, and I'll share that later. Consumer education has become more important and more accessible, right? Transparency through manufacturing, we're demanding it, and consumers have more options in more places, supply and demand. I know for certain 10 years ago, there were very, very few green building options. 20 years ago, it was an elitist thing. Now it seems very, very common. We have customers in places like Kentucky and Montana and Idaho and California and Utah and Arizona and Michigan and all over the world, all over the country, are leaning and working towards a better built environment. And we're doing this quite well, again, because of some of these things on this bigger scale. We are building better big buildings. And this is where I think this is really important, because when we think about going from our homes to the next building, right, it's pretty easy to build a pretty healthy home space, but it can be really, really difficult to build a really big building space. And if we're in that building, I know my kid's in a school for 8 hours a day. I'm in an office 8 hours a day. You're somewhere 8 hours a day, perhaps more. The museum, the ferry terminal, the airport, these should be places that are not toxic. The interiors of both commercial and multifamily buildings have become healthier. This is a big idea, and this is the big idea for behind sustainable and ecological and healthy building. People can't work and won't work or buy sick buildings. I mean, that's going to become the reality. I think it is the reality, but more and more, if the building isn't healthy and sustainable and ecological and eco-friendly and energy efficient, it's going to be a rusty old crusty building, and it's going to lose its value pretty quickly. Cost of building is high. Proper investment in people and the planet. Let's do this right. We are doing something on a bigger scale. You're seeing this happen in proper investments. You know, I am going to look at the example of the Climate Pledge Arena. We did not have to build a super green arena here. Very few cities, states, countries build huge, 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 super sustainable buildings. It's not something we really have to do. It's something that we have a goal to set. Many of us do for carbon neutral 2030 or carbon negative 2050, whatever those targets might be. But the fact that it's happening is a big scale fix. And buildings are becoming more efficient. They truly are becoming more efficient from a small scale to a grand scale. People are respecting smaller spaces and tinier dwellings. Those are pretty efficient. So that's helping the smaller home scale output some of our carbon, if you will, and output of chemicals and use of chemicals, and better air quality for all. So what can you do? How can I take action where I sit in this cool group of Northwest EcoBuilding Guilders and folks? Community input and getting involved is the biggest thing that I think is an action. Big building projects. When those billboards come up in your neighborhood for those 5 homes that are going to get torn down, for the museum that's going to get slated to get built, for the project that's going to get done for the City Children's Museum, go to that meeting. Go ask what sort of flooring are we putting in it. Go ask what sort of paint we're going to use. Support it and invest in it. You know, put your green dollars into green businesses. Obviously, vote. You know, so many of us, we live in places that are greener and healthier. We have sustainable goals and things, and it's great to be where you are. And I do think that is an action item. Educate yourself on air quality, inside and out. The how, the why, the what, the where. Educate yourself on what might be making you sick or what you might be thinking you sick. We do know that there is tons and tons and tons of information and resources, people like Risa, organizations abundant. Obviously, big players, big names. Some of us trust those big names, some of us don't. But there's a lot out there to research and to educate yourself on and ask questions. We're here from a building materials side. What makes one better than the other? Why should I make this selection over the other? Tell me more about the chemical components and how the care and the maintenance and everything works within my home space. You know, making sustainable choices in your home and your life. Stay away from the stuff. Bottom line, you know, if you can stay away from the stuff that's going to be the best, And there are definitely options, especially when we're talking about some of the simple steps of like your home cleaning products. You know, are you burning candles? You know, do you have a gas stove? There's a lot there to unpack. Make your kid not have the blanket for 5 days because it stinks, you know, make them think about it. And seek solutions to mainstream building products. Again, I come from the building products industry. These aren't really questions. These are the answers. No vinyl, no PVC, where you would put in a bathroom, where we would put in a kitchen, where you would put in a laundry room. Use linoleum. It is a natural-based product. We harvest this product. No synthetic fiber, no carpet, no synthetic fiber carpet. There's no such thing as a healthy plastic fiber. It is a microplastic, it is a microtoxin. There's just no such thing. If you're going to use carpet, use wool, 100% hair. No plastic, sticker, wood looking products, right? Use cork or use real wood floors. No composite or wood cement boards, right? No PVC/composite wood. Stay away from cement boards. These all attribute to bad outdoor air quality. When you're cutting cement board in the outdoor air quality, you know, there's so much to unpack there. Use natural wood. Consider thermally modified woods in the marketplace that are replacing composite wood, non-performing domestic wood products, and certainly cement boards. And I think kind of a no-brainer, especially to this crowd here, you always are using low VOC stains, paints, finishes, cleaners, really anything that you're going to bring into your home, or that you're going to put in a building or on a building, or in and around my kids and my house and my people and my family, my sacred place. It's got to be something that is low VOC, low toxic. There are definitely things working. Consumer power and demand. Keep thinking, keep working, keep doing, keep talking. It's working. I've been doing this for 20 years now. There has so much change. I know there's veterans in this crowd. So much has changed for the better. And so keep up. Cities, states, countries are involved, engaged, demanding and taking action. Look around the world. Look at what is happening in different parts. Material suppliers, manufacturers, architects, builders, consumers, they're all thinking and taking an action on the same page. Our communication is working. We all are starting to think on the same page about sustainability. We all are looking at toxins and products. And I think the more that we look really deep at these suppliers and manufacturers and really support those ones that are really doing that, that are really reaching out at this level, at a higher level, those are the ones that we really, really need to be engaging with and really, really asking some of these hard questions and make them keep working, make them keep thinking and doing. Places like Green Home Solutions are working. We've been in the industry here for 15 years in our brick and mortar store. There's tons of places and people in this organization, people like Riza, people like folks that are in this list of the Northwest EcoBuilding Guild that started doing this a long time ago with me and some before that. So you are working. So thank you for continuing that. Let's stay in touch. I'm here available at Green Home Solutions. If you're not familiar with us, if you're here in the Seattle area, we're located just southeast of the Ballard Bridge, kind of in the North Queen Anne neighborhood. We're a super fun, beautiful, wonderful, healthy, inspirational space. We hear 3 to 5 times a day someone come in and go, "Oh, that smells good in here." And that's what building materials should smell like. I challenge everybody to go to your Home Depot and take a whiff down the flooring aisle at Home Depot and have that same positive reaction. "Oh, it smells good in here. I want these in my home." So So thank you all very much for listening and giving me your ear, and I appreciate all your time.
Thanks. Thank you so much for that presentation. That was fantastic. And I can agree, I have had the opportunity to visit Green Home Solutions many a times and can concur, it smells wonderful in there. Thank you so much, Peter and Risa. We'll open it up for last questions from folks. There was a couple that haven't quite been answered yet in the chat that we can go ahead and start with. One of them I saw was Bragdon Shields. This might be a question for either Risa or Peter. He asked, are box fans and MERV 13 filters effective? So that homemade filter, if you will, maybe during a smoke event or when filtration is needed or to help support that. Is that an effective means of filtering your air?
I'll take that just because I actually had to measure one.
Yeah, that's reason for sure.
So yeah, so I actually had a client and they had, I think 2 or 3 that they built. And I was really hesitant because I was like, this might be some interesting readings. And I can't remember what MERV filter. I think it was like a 13, but it actually did a fairly decent job filtering out the particles. I was surprised. Now, MERV 13, remember, it's not going to filter down the super fine, the ultra fine particles, but for just the normal particle size, like down to 0.3 micron, I thought it did it did a much better job than I thought it was going to. Do you want to add to that, Peter?
No, I mean, I've got a couple different high quality filters at the house. I run a MERV 16 on my central air system. I for a while there, when I was at Environmental Home Center, we did sell a couple different types of hospital grade filters, and I've got one here in my office. And I definitely think it's important to look into those types of things, especially, chemical sensitivities. I think for someone who's really chemical sensitive, I do know that there is a group that I'm familiar with, NVL Laboratories, perhaps Risa, you are as well. And don't quote me on this, but as far as I know, they can come in and actually run filtration in your home, take that data back, analyze it, and come back with some data and information as to what it is, how it is, what size it is, and perhaps they're being able to really determine, should I be running, how much filtration should I be running? I will say this, especially during times of smoke. We've had construction going on in the neighborhood. We had some tar roads that got done in front of our house that was awful for a few days. And definitely having to crank up the air filters, and a couple of them aren't that great. Any air filtration is going to help at some level, cleaning the air. I definitely have learned that the more clean air you can bring in, the more bad air out is often the solution. And I tend to go over and above. We've had it where we've had flooring products. People have called us and asked us for help. I've purchased a flooring, or I've installed some carpet. It's really smelly. What do I do? Open up the biggest window or door you can, put 4 fans there, get all that air out of there, and bring in some fresh air. And again, you got to just bring it in the fresh. So
yeah, the other thing too, so as long as your filter, and this is also where you're going to see a price difference, is it's the carbon filter is going to absorb the VOCs. And so the less expensive filters, they're not gonna, like, their carbon filters they're gonna be pretty thin. So and I think, if I'm remembering correctly, I think carbon filters can absorb up to 1/3 of what their weight is. So for example, if you were to look at, an IQ Air, those cost about like $800 compared to, some of the other, like, I don't know, Austin Air or Air Doctor or something, they can be less. And so that's where you look at the particulates, and then you look at how heavy and how big is that carbon filter in there for things that smell. And what I've seen for off gassing, like I had a client who they bought a brand new house last September, and she was still feeling symptomatic when I did her place in December. And it's just, yeah, and she's finally starting to feel a little bit better because she's able to open up the windows, and she also has a really expensive, very good air filter that also has a really good carbon filter along with that.
I just put into the chat there a link to the filters that we used to sell when I was in Environmental Home Center, and I had a lot of good experience with it. I do run these. I actually have clients who run these in their car. Some of our real highly chemical sensitive folks, Aerox. So I put a link to that. Do check out that. They are a phenomenal brand, real simple. They have coconut fiber, a couple different fiber options, and a couple different filter options. I do know that there are customers who will be and have allergic issues with bituminous coal and some of the other things that are in those filters. So therefore, then you're running like coconut fiber filters and some of the other ones. So, yeah.
And sometimes it's the packaging too. Like they'll get the air filters. So the other group that I've been working with, a lot of practitioners are very vocal about some of the just like the air filters because of the packaging that the air filters come in.
It makes sense. I mean, I hate to say it, the filters that I buy from Aerox come in a big plastic bag.
They all do, yeah. Or the carbon off gases for a little bit because
yeah. No, it actually on Aerox, as it says, run outside for up to 10 minutes prior to bringing it inside to kind of, get it running. But
That's what we do with our filters. When ordered, we just place them outside just for a little bit and then bring them in. And as a renter, I will say the MERV 13 or 15 or 16 or higher that you can find attached to a box fan during a smoke event is very effective running in the house. We do that as best we can while also running our COA HEPA MERV filter as well.
I think a lot of that during the fire season is just change them out fast. If it's really bad and you gotta do it, it's like it literally could, they're cheap. Buy the thin ones, put them in, put them out, put them in, put them out. That's because otherwise they're gonna stop working real fast. Yeah.
Yeah, I always tell clients to have a spare, like at the beginning of summer, just have check your air filters and then buy a spare because you never know if it's going to be fire season around here or how bad it's going to be.
That's right. It could happen in a matter of hours.
Yeah.
For that tip. Are there any other questions for our speakers tonight? This was really great and very informative. I look forward to using this knowledge now in prep for this summer. Any other questions for our awesome speakers tonight? Erin, did you have something? Oh, maybe not.
No, I'm not gonna question. I just want to say thank you. It's been great. An important topic that's usually missing from the high performance building conversation. So I'll do this work too.
Nice.
Yeah, thank you.
Yeah, you bet. Thank you. Thank everyone for attending.
Yes, thank you.
Yeah.
Glad that
Yeah.
I got a question.
Oh yeah, go for it.
Sorry, I just biked. I was So, back in the day, there used to be an idea, I think it's called hot boxing, where they would turn the heat up on the buildings to let them bake out all the VOCs and stuff. Is that still done anymore? Or is that ever done and that was just a myth?
Well, I can speak to that. It's definitely still done. You'll see a lot of times big propane heaters with big vents and big things going up into usually multi-unit townhomes projects. You will always see it in commercial buildings. Now they kind of really think about it, John, more of like temporary, indoor air heating and conditioning, right? So they're bringing in sometimes cool air, sometimes they're bringing in warm air, to bake it out. I think that term, no, I don't think so.
Yeah.
But it certainly is to expedite and speed up the process.
And it works a little bit. I mean,
Well,
seems
sure
like
it
we're still
does, because it definitely works. Because, if we think about bringing, as I said, it's kind of the real simple facts, bringing all the bad air out that we possibly can and replacing it with good air. So that's achieving that, right? We're blowing all that
Oh, yeah.
bad air out
Oh,
and
yeah.
bringing in good air. And then we are essentially spinning that, so let's say it's drywall or paint or an adhesive, right? We are spinning that air quicker out of the building rather than trapping it, condensing it in
Yep.
that building. So we're getting rid of it. It is a downside of it that we are just blowing it right out the next window. Here we take all this, drywall odor, or all this paint odor, or all this finish odor, and we're blowing it outside. We don't have a choice, unfortunately, when we're talking indoor air quality. But so yeah, that is the reality with those bigger systems that you see running. They're certainly expediting the process of curing, drying of the materials and building, and definitely moving a lot of air.
And there's more activity at that higher temperature. So remember when I was talking about like at higher temperatures, there's just more activity with the gases.
Yeah.
Because the gases, they're not gonna be settling. Now it's all of a sudden it's really hot, so they're gonna stay in the air and be circulating around even more. And then back to Peter's point, right? You're just kind of sucking that out and spitting it outside.
Yeah, there's significant data between chemicals that are off-gassing from certain floor products at temperatures of 85 degrees and 110 degrees, which is not that uncommon for a floor surface to get at. And it is astronomically higher when that floor surface is 85 degrees and when it is at 65 degrees. And it only makes sense, right? When things get hot, they move. This is particular.
Oh yeah, but it's like a question of like I always say, it's just it makes you feel good, like it's doing something. But I always thought like, okay, to really get something hot enough that it's actually going to help off gas those things, you probably have to get up like 200 degrees or something like extreme.
No, definitely
Like
not. Definitely not, John. I think, yeah, no, definitely not an extreme heat. A lot of our building materials, adhesives, coatings, they start to dry at 65 degrees. Their optimal drying temperature might be 75 to 85 for a full cure in 24 hours. So yeah, no, it's not a whole lot of heat temperature to do that. Unfortunately, yeah.
And I guess I had one more question about the fact that carbon filters are what handles VOCs is kind of news to me. I feel embarrassed to say that. Can you talk more about that? Carbon filter. So HEPA filters don't take care of any VOCs?
Well, it's a lot of HEPA filters do have that's a carbon pre-filter.
Okay, they do have a but it's the carbon filter, not the woven.
HEPA is particulates. So think of HEPA as like sucking all of the pollen and like the stuff floating around in the air. But
Yeah,
when the smells and the gases, that's VOCs, which is going to be absorbed by carbon.
Change it. It's wide open, so I can make it.
Oh,
John, we're here. Yeah, so definitely that's why that link to those Aerox products, that's one of the very few filters that actually pulls VOCs out of the air. It actually grabs those toxins because it is a pure 100% carbon bituminous coal filter replacement. So yeah, they're one of the very few where you're literally trying to scrub chemicals out of the air. And again, that's why I've had people, their car model is crazy. It literally is like the plug-in car model to your cigarette light adapter, and you can run it. You run it in your car the whole time.
My wife is gonna want that because I leave my stinky gym clothes in the car, and she gets mad. They'll take care of that, right? So I don't have to ever bring in my gym clothes.
Yeah, I don't know about that, John. I don't know. We've met, buddy. I don't know.
Thanks, John.
Aaron,
Aaron,
more brief question about you were saying how radiant. I might have missed this. You're talking about how radiant floors are not. What's the problem with radiant floors? Why do we recommend
Oh, yeah, that's a
radiant
good
walls?
question.
Because it just heats up, so it heats up the air layers. When you have an HVAC system or a baseboard or, like the wall units, like the forced air, what happens is you get stuff in the ducts, right? So dirt, dust, bacteria, and then it blows out.
Well, that's not radiant floor though. That's,
Right. That's why. So so from an air quality perspective, you don't have as much stuff that is being, pushed out through dirty air ducts or
oh,
what
so that's
have
why
you.
radiant floors are good.
Yeah.
Oh, I
Someone
thought you
was,
said,
someone said earlier that radiant floor heat is not recommended, and that's why building biology recommends
Oh yeah.
radiant wall.
So building biology.
Walls.
So building biology, so there, and again, like I said, there's a lot of active discussion about that, but I didn't make up that recommendation. But the thought is that because they want the ambient temperature to be, between 68 and 75. So if you have radiant floors, your floor temperature is going to be hotter, and then,
so,
3 or 4 feet above the floor, the temperature is going to potentially drop. So the thought is that if you have radiant heat from the walls, your ambient temperature just overall, like surface to ceiling, and just overall in the space is going to be more evenly distributed.
From a convection and thermodynamic standpoint, I would think that's not. I have a hard time picturing that.
well, I think I could picture that if it's a really leaky house. But if it's a nice, well-sealed house, passive house or so, you're not gonna have that stratification. You're hardly, yeah, it's every surface is gonna be, so that's another reason. I think they're getting at trying to minimize stratification of air layers.
Right.
Right?
Yeah.
Is what is that?
Yeah. But
And
but the challenge with walls, right, is if you put something behind the wall, or right, you've got.
oh yeah, it's not gonna happen. That's just
I mean,
that's
exactly.
not a realistic solution, but building your house with a better envelope so that you don't, so that when your radiant floor is the same temperature as your air temperature, you won't have that stratification, and therefore you're healthier.
Yeah.
Like a passive house.
Yeah.
Right? I mean,
I would think to the wall thing with heat, right? Like you see a lot of the European flat wall heaters, right? And then the radiator heaters that were on the walls and how those sort of, they take that cold air, kind of circulate some of that. You know, I do think something in terms of like heating a space would be better to do that on a wall unit than say, putting a space heater in the middle of a room or a floor, circulating air. I think there's probably some thought to that data there that building biology is working with as well. I mean, that's the old hydronic radiator theory.
Interesting. Okay.
Thanks, John. Did anyone else have any other questions? I just want to be mindful of everyone's time and do a quick time check. It is 8:15. I'll let the meeting go for a little bit longer, but I just wanted to wrap up and say thank you again so much to our speakers and our sponsors this evening. Really appreciate the time you took to share your knowledge in this really important topic. And I look forward to continuing the discussion if folks want to stick around for a little bit longer. But until then, see you at the next Guild event and stay tuned for our upcoming hybrid education events. And thanks everyone for engaging in the chat. I'm looking at some really great discussion right now. Really appreciate it.
Yeah, thanks everybody again for coming. Appreciate it.
Yeah, thanks everyone.
Appreciate you all. Yeah.
thank you guys.
Yeah.
Thank you so
Thanks,
much.
John. Thanks, Aaron. Thanks, Linda.
Thank you.
Thanks,
Lisa,
Leslie.
you gotta come to Green Home if you haven't been in.
I will. I'll come find you.
Yes, please do.
Peter, are
Yeah.
you the
Smells
owner?
amazing.
Wait,
Yeah.
no, you said you've been with them for 8 years. What's your title or role there?
I've been here for I've really been here since the conception of the business.
Okay, cool.
Yeah, been involved with it. Known the family members that started it for quite some time. Grown up here in Seattle through a friend of a friend. So yeah, you know, my primary role is well, many hats. Really, the outreach to the A&D community is a big part of it. I spearhead our trade sales department and work with our product development and branding and researching, developing, and looking at products. You know, we are often tasked with, you know, manufacturers will come to us and say, hey, I have a floor product. And we go, yeah, that's cool. Or I have a siding product. Oh, that's really neat. Let's look at it. Tell us the story. Let's get involved. Do we throw it out the window? Do we keep it in the doors and bring it to the market? So, you know, we sit down and strategically look at that. And
Cool.
really how we differentiate ourselves in this building materials market. And we do a lot of that homework and legwork for you to figure it out, to simplify it. You know, not throw the next best thing, hopefully throw the best thing, because we feel we've put that energy and time behind it. And yeah, so amongst a few other things, yeah, I get to present to folks and often do work direct with the manufacturers that we work with, and you know, coordinating with them on how to get into that A&D community, get these products specified, continue the conversation. So,
Beautiful.
yeah.
Right on. Good work. Thank you.
Thank you.
Oh.
Yeah,
I'll come visit one of these days. Excellent. Through on
Yeah.
a weekday.
yeah, come on up.
Oh, you should.
It's cool. Yeah, John's been in many times.
Are
Rides
you
his
guys
bike
gonna start carrying tile again?
No,
Yeah, no.
just
That's
you
my-
know, we have the clay house and that's it. You know,
Oh, I should be there. I haven't been there a while.
yeah, come look at clay house. But yeah, you know, just super grassroots in the tile world. It's a strange world, that tile world. We'll stay out of it.
Oh yeah, I probably, yeah,
Yeah.
sure.
Yeah.
Yeah.